Did you know EV charging is growing and getting bigger every year? It's almost impossible to keep up with the changes. Managing the use of charging systems is critical to the electrical system. Charging stations can be programmed to reduce peak demand charges and communicate a variety of information. On this episode, we'll show you what and how to specify EV chargers, and this technology is changing rapidly. Hello and welcome to the Power Grid, the podcast that helps you build reliability in your electrical system and gives you confidence in your power. I'm Brian Brannigan with Power Protection Products, where we've been solving power quality problems for almost 30 years. So on a hot summer day at the grocery store, the freezers were working as hard as they could. The coolers were working as hard as they could. The AC was working as hard as it could in the grocery store, but also outside in the parking lot were EV charging stations that were working as hard as they could to charge vehicles. This pushed up the peak demand of energy for the grocery store for that day. And this didn't have to happen. With the right selection of EV chargers, you can actually control the peak demand of your energy usage by controlling the charging stations and how and when they charge electronic vehicles. And that's the beauty of the technology of electronic vehicle charging stations. This didn't have to happen if the right EV charging stations were purchased. We can now control the charging time, we can control the energy used, and the time it's used in order to optimize the electrical system at the right time. Using smart digital breakers at the charging station can control the energy used and the time that it takes to charge a vehicle. The use of proper communication technology can be applied to interact with the actual facility electrical system to adjust resources for charging to meet the total system demand and reduce the peak demand during the peak time. We'll go to the one thing we want to take away from the episode. EV charging is simple, but it can be costly if you don't control the EV charging at the point of the charger by using a smart breaker technology. Typically, you'll see level 2 charging stations outside of a facility, whether it's a grocery store or a hospital or parking lot. And these level 2 charging stations can be controlled by electronic breakers that can actually reduce the peak demand charge for the facility. There's also level 3 charging stations that you'll see that will do more rapid charging. And you'll typically see these in groups along the interstate or in large high-speed charging situations. When putting a charging station outside of a facility, it's important to understand that there's going to be damage. There's going to be some harm done to the charging stations. People will steal the wires to the charging station. They'll actually steal the cords coming out of the charger. They'll run into the charger. So it's important to know when the charger is working and when it isn't working. And you can do that with smart charging technology. We use a smart breaker to actually adjust the charging speed of the vehicles that are trying to be charged. And we actually can communicate to a central hub of what's going on with each charging pedestal by using the information provided by the smart breaker. It's time to rethink how we recharge and what we use for charging stations to include the concept of reducing the peak demand and using breaker technology to control the charging rate and time and speed of each pedestal at the charging station. We can actually reduce your peak demand by reducing the energy available at the charging stations during the peak demand time. Now, peak demand can happen in the summertime or it can also happen in the wintertime, depending on what part of the country you're in. So it's important that your charging station can actually participate in controlling the peak demand charge on your utility bill. Using static power management will optimize the existing infrastructure to charge more vehicles while avoiding breakers tripping. But dynamic power management will adjust charging levels in real time to avoid peak demand charges using smart metering technology. This will enable you to coordinate better with your electrical system. There's very few charging stations out there that actually have this smart breaker technology. Atom Power is one of the ones that we recommend and use. So what to look for in a charging station: speed, reliability, and cost effectiveness. For reliability, you want it to be monitored 24/7, 365. You want the faults in the system to automatically clear, and you want some sort of cable management system in place. For fast charging, you want to have at least 80 amps of speed all the way up to 20 kilowatts. And you want it to be scalable. Charge up to 10 times more vehicles with the existing infrastructure with software defined and programmability. You want it to be cost effective, up to 57% savings in your total cost of ownership over 5 years, and up to 46% savings with dynamic power management. You want it to be secure. You can have a dual listing as a circuit protection device and an electronic vehicle charging station. You also want this rated for over 200 kilovolt amps. The one thing you want to take away from this episode is that EV charging is simple, but it can be costly if it's not controlled at the point of charging by smart breaker technology. Thank you for joining us on the podcast. If you want to learn more about the technology behind EV charging stations, the links are in the show notes.